In this video, I'm going to walk you through Lesson 12 of Unit 8.1 from OpenSciEd. In Lesson 11, we were introduced to thinking about designing a protective case for something that needs protecting, like a cell phone. And so we navigate into this lesson by considering the criteria and constraints that we set up in Lesson 11. We think about what does it mean to have good materials that are protective, and what is the purpose? What are those materials going to do? And how do we think these materials function? And we bring up the idea of how we think these materials will reduce the peak force of energy transfer, bringing back those science ideas from the first and second lesson set. And then we're going to think back to how we measured peak force in those past investigations. Now, this is going to bring up some ideas about using those spring scales again, and how we use that twist tie that's wrapped around, and we can really measure peak forces using that setup. So we're going to repurpose that setup for our investigations of different types of materials. So before we do this, we're going to predict the performance of different materials. Here's a handout. You'll make copies of this and you can cut it out so that they can paste this in their notebook, or you can have them just write in their notebook or talk about it. But what do we predict is going to be the best at protecting or reducing peak force? Which material do we think would be the worst at reducing peak force? So we start thinking about these different materials that we're going to test with our setup that we have with our spring scales. And then we're going to get back into investigating with those spring scales. Now, here is a teacher reference setup. So you can see that we're going to use a ramp out of some type of rigid material. If you bought a kit, it's probably like a vinyl plank of flooring. And this brick is to keep it in place. And this track is what the cart will roll along. And you're going to need to have two carts with spring scales. One is going to sit at the bottom of your ramp, and the other one's going to roll down the ramp into the other one. And these are electrical plates, and the material is going to be between these electrical plates. But before we test materials, we need to first figure out what our baseline is and how much that peak force is going to be when they hit against each other. Here is a review of how we will test the materials. You will need to have a printout of this at every group table. And so going back to talking about the setup, you can see that there'll be electrical plates taped or with sticky tack onto the plunger. And then they're going to have their first readings without any protective material. This is our baseline. We're going to do several trials. We're going to average it, and we're going to figure out that, this ramp is creating a peak force when they when they collide into each other of a certain amount of newtons. Then we're going to use that as our baseline. And so when we have a reduction in the peak force, we take our baseline and we subtract it with the newtons we get from this one. And then we figure out how many newtons the material reduced in that peak force. And so you can see we're going to put bubble wrap on both of the electrical plates, and this should be a lower or a decreased number of newtons when they collide into each other than would have been without the material. Before we can do all this, we need to make sure students know how to calibrate the spring scales. Here's a slide to support you. Basically, you twist that end to get that little line there on the plunger is going to be at 0. And once we're calibrated, we're going to go ahead and start our investigation and collect some data. And we're going to add it to a class chart. Now, you might have a different numbers here, but they should be along these lines because this is a reduction in newtons. So no matter what your ramp size or slope is, you're going to get about these numbers. So go ahead and average in the class what everybody gets, and then it should look something like this. And then we're going to analyze the results and determine who our top performer. And then we're going to analyze the results and determine our top performers. When you do this, we're going to look at which were the best at reducing peak force on the non-moving object. What patterns did we see? And so we're just kind of thinking about the materials, and we're going to think about what structural differences are making these top performers do this job of reducing peak force. So with that, we're going to think a little bit about what happens if we compare spring scales. We don't put them on the ramp. We just put the materials between the plungers. And when we do that, we use one as a 10 newtons and one as a 5 newtons. And we realize that the newtons are still the same on both sides. We figured that out earlier in the unit, but we have to press a little bit harder to get that same number of newtons that we got in our investigation. So we realize that there's something that's happening in the structure of these materials. So then we decide to look at the images close up. And so we're going to hand out some images of the materials that are taken under microscopes. I would print out one per partnership. And let's take a look at these. You're probably going to have to reformat this doc. I've done a little bit of that on this one. So we look at metal under a microscope. We see it's pretty flat. Cotton fabric looks like it has some valleys and ridges or something like that. Cotton fiber, interesting. Okay, styrofoam, it looks like it has some big holes in it. Bubble wrap, also kind of some holes in it. Same with the earplugs. Anyways, you're looking at these different materials close up, and what we're trying to have the aha moment is the top performers have these structures that have air holes in the middle of the material. So that has something to do with how it's reducing the peak force. So we use all that we figured out to construct an explanation. And this is actually going to be a bit of a model. They're going to zoom into the protective materials before the collision and then just after the collision. And so we're really coming back to those ideas of deformation, what's happening to the materials when the collision happens. Okay, so that is a pretty long investigation, 2 days probably for lesson 12. And let's talk about the materials prep in the next video.